In question 5, we've been provided with 6 graphs, and we've got to try and establish which equation matches with which graph. The first thing to do when you're looking at this is just to recognize what type of graph we've got, what type of function we've got in each of these instances. And just by looking at that, we should be able to see that A is a quadratic, B is a cubic, C is an exponential, D is a quadratic, E is an exponential, and F is also cubic. So we've got that at the back of our mind, just looking at the general structure of the graphs here. And then we're going to come along and look at each in particular a function. So in part 1, we're looking for a cubic, which has got a positive intercept. So the two cubics we said were B and F, and we can see clearly that F appears to go through the origin. So B here is going to have the graph that we're after. So x cubed plus 1 is going to be B, and we should check that on our calculator just to make sure. Part 2, so we're looking at a quadratic here. So we said the quadratics were either A or D, both of them having that characteristic shape there. So here we're looking for a quadratic which is going to be U-shaped and have a positive intercept. So we can see they've actually both got positive intercepts here, but the fact that D has got a U shape means that it is x squared. If it's an upside down U shape, that's going to tell us it's negative x squared. So x squared plus 3 is going to be graph D. The third one, y equals 4 minus x squared. So we've just talked about that essentially. This again is, well, also by process of elimination instead of the quadratic, but similarly we can see that this is going to be, it's got a positive intercept here of 4, but the fact it's negative x squared tells us it's upside down quadratic shape. So that's going to be A. Question 4 then. So this is the first exponential function we have. So we can see that the exponential form here is 2 to the power x plus 1. Now we know for any, if we just had any exponential function here, a to the x, we know that this coordinate, whatever a is, will be the point 0, 1, because anything to the power 0, so when x is 0, will also give us 1. So we can say that in this instance here, we've taken our function and it's been shifted up 1. So this point should actually be the point 2. And we can see that because it's just a to the power x, positive x, it's going to have the shape that we kind of associate with an exponent here. So this one is going to be E. For part 5, we can see again it's an exponential function, but the exponent is actually negative, which means it's been reflected in the y-axis. And we can see up here that again this kind of looks like the exponential shape, but it's been reflected about the y-axis. So this one is going to be C, and then by process of elimination it is F, but just to explain why, this is also a quadratic, and we can see that there's no constant term here. There's no constant term, which means that the intercept must be 0, so that one therefore goes through the origin as well.